Hello, welcome back to the video lecture series for Introduction to the Art of Programming using Scala. This is the first video in the chapter on sorting and searching, and I kind of want to introduce the idea of sorting here. This really is a very straightforward idea. You're given a number of things, and you want to put them in a particular order by some comparison function that you would have. That's the formal way of stating it. Many of you probably at some point early in your education had to do things like you had a list of spelling words and you had to alphabetize them. I know I remember doing that a lot, and I remember helping my daughters do that same assignment. That's a sorting assignment. Okay? You have a bunch of things, they're out of order, and you need to put them in a particular order. And in this case, the order that you want is alphabetical. So the based upon how they would be found in a dictionary. We can also do sorting by, say, numbers. If you have numeric values, maybe we want to sort students by their grades. Maybe we would want to sort students by their names. So to help illustrate this, I just want to look at, imagine we have an array, and it has a bunch of different values in it here. Now, one of the things about doing sorting is that how you would sort things. So if I ask you, okay, so I give you a bunch of things. Maybe it's, maybe these are envelopes, there are folders that are in a filing cabinet, and you have to put them in order. Maybe these are cars. Imagine you're a parking attendant, and for some reason your boss is completely OCD, and he wants all of the cars parked in order by their license plate or something like that. Okay, so you can imagine different things you want to move in different ways. A similar type of thing to the cars would be if you go down to a weight room and all of the dumbbells are in complete disarray, and you want to sort them from smallest to largest, or maybe you work there and it's your job to sort them from smallest to largest. How would you go about doing this? And it turns out that based upon what it is that you're sorting, you're going to do it in very different ways. For example, the file folders are very light, they're very easy to move around, and you can actually push them around inside of a file drawer. On the other hand, cars in a parking lot can't be pushed around. It's a significant amount of effort to move them. We're going to focus mainly on sorting arrays. Now, sorting lists is actually a slightly different problem. And in some ways the lists are almost a little bit more like the file folders. Arrays are kind of like the cars. So if you imagine an array like this, the reason it's like the cars is because if I pull out the 3, I can't just take it, when I pull out the 3 here, it's not like I can just take everything else and it just moves down automatically. I actually have to move them one piece at a time all the way down, and so it takes a fair bit of work to move something out in an array like this. Okay. So how would you go about doing this? Okay. We want to formalize the process of how would you go about putting these things in sorted order. Okay. What did you do back in grade school when you had to alphabetize a list of words? I know for me, what we often did would be to actually write the words on little slips of paper so that I could reorder them, and that way if I did something wrong, I didn't necessarily have to rewrite an entire list of things, because at least for a human, I was fallible, and you might find something, you think it goes someplace, but then you realize, oops, I missed something else. The computer's not going to mess up in that way, and so that does change the way we approach the problem. But some of the ways in which humans approach things might be good for the computer, and some of them might not. So for example, if I were to give you a large stack of file folders, a common approach that people take is to break that into smaller stacks. Okay, so for example, if you were alphabetizing a large number of names that were on these folders, because the folders are very easy to move around and because they're small, you might actually be tempted to make one stack that is everyone whose last name starts with the first 5 letters of the alphabet, and then another stack for the next 5, and so on. And so you wind up with a number of different stacks. You've made your problem smaller. you can sort those individual stacks, and then you can stack things back together again. When humans are doing this, they're generally not all that formal about following an exact algorithm. Okay? But when we tell a computer to do it, we're going to have to follow an exact algorithm on how we do it. We have to very meticulously specify this is the approach that we're going to take. So for example, the way that I would often do my alphabetizing words was I would go through and I would look for the thing that comes first in my list, and I would move it over. And of course I could move things around. I didn't have to keep them in the same block. And then I would look for the next thing and I would pull it out, and I would look for the next thing and I would pull it out, and the next thing I would pull it out. This is very similar to what we're going to talk about, which is one of the sorts we're going to talk about, which is a selection sort. However, when I was doing this, I could have two separate lists, and when we're sorting an array, at least, one of the things that we want to typically do is to do our sort in place. So if I have an array like this, I don't want to have to create a whole second copy of the array. I really don't want to have a blank array and copy things down to it. I want to be able to do all of my work in this one array, perhaps with one extra temporary variable. In many ways, if we go back to the car analogy, imagine that my parking lot is pretty much full. Okay, so I don't have a whole second parking lot to move the cars into in sorted order. I have to utilize the space that I already have, and maybe I have one space off to the side that I can use to hold cars temporarily while I'm moving them around. This is actually exactly the setup that we're going to use for the sorts that we're going to do. Is we're going to try to take all of these elements in the positions that they're in here, and try to sort them. And we're going to go through some different formal algorithms, and we want to talk about how fast these algorithms are, and in particular how that speed changes with the number of elements. And when we talk about speed, we're not actually going to be talking about it like in seconds, because obviously that changes by computer. You get a faster computer, it takes fewer seconds to run. Instead, we're going to talk about it in terms of operations. So how many times do I have to look at various elements? How many times do I have to check whether one element comes before another? How many times do I actually have to grab and move elements? Because each of those things has a cost to it. In the case of, for example, moving cars around a parking lot, looking at the license plate might not take much effort, but moving a car to a new spot does take a lot of effort. In the case of file folders, looking and comparing names might actually be more effort than actually moving the folders. And so we'll pay attention to both of those, and those tell us what we refer to as the order of the algorithm that we're doing. So in the next several videos, we're going to go through and we're going to look at three different algorithms, and these are all fairly simple algorithms for doing this, and then look at how we can code up those algorithms. So that's it for this video. Hopefully you can see where we're going with this, and in the following videos we will actually develop three formal algorithms for doing this. They are not the only three algorithms. There are many other algorithms, but these are the ones I'm going to focus on here at this point. They're not even all that great of algorithms in some ways, but they're easy for us to understand and they're easy for us to code, and so that's what matters a lot at this point.